Alright, in this video we're going to look at the graph of the inverse function. So here I have pictured the graph of a function in blue, and first note that this is a one-to-one function because it passes the horizontal line test. So namely, if I draw any horizontal line, it will intersect this blue graph in only one point. So it is one-to-one, so its inverse does exist. And what the inverse function does is just reverses inputs and outputs. So in other words, it's just going to swap x and y coordinates. So I'll go ahead and swap x and y coordinates for each one of these labeled points in blue. And I'm going to get these three labeled points now in red. And we notice here that there's some nice symmetry between the graph of the function f in blue and the graph of its inverse in red. Namely that the two graphs are symmetric about this diagonal whose equation is just y equals x. Right? You can think about taking this blue point and then reflecting it over this green line to get this red point here. Okay, now notice at the point 3, 3, we're actually on the diagonal, and the blue and the red graph agree there. All right, so looking at question 7, it says, fill in the blank, the graphs of f and f inverse are symmetric about the line, well, y equals x here, this green diagonal. All right, and then question 8, really similar to what we see right here, it says, the graph of f is shown to the right, sketch the graph of f inverse and label key points. So just like we did up here, to solve a problem like that, again, first just swap the x and the y coordinates for each one of these labeled points. And we're going to get these 3 points now. And that will be the graph of our inverse, right? You don't have to put in the diagonal. If you'd like to, it would look like this. Notice here, again, the red and the blue graphs, they cross at the diagonal there, where the x and y coordinates are equal. But that will, yeah, that will do it. Thanks so much.